we traveled all the way to Taiwan to visit ORA Engineering, one of the most advanced steel and titanium frame manufacturers in the world. I'm here to work on a few projects, learn, and solve a mystery that's been haunting me. How are bike tubes actually made? ORA is one of the few manufacturers who forms their tubes in-house, so I was hoping they could answer this question.
Hello, nice to see you here.
Agnes is the daughter of Jim, who is the founder of ORA Engineering. ORA makes thousands of steel and titanium frames per year, including our new house Hummingbird. They make great bikes, and every time I visit, I learn something new. I truly enjoyed making this video, and I hope you do too.
3, 2, 1, go.
All right, tell us where we're at.
We are in CNC area.
And what do you make here?
Usually we make a small part here, like a BB shell and a cable and something drop out like this one.
Okay. And then why do you make all these things here?
There is 3 reasons for that. One is because the quantity is not a big one. Another one is the quality, especially like a cable. We have do a lot of details there and good for the welding process. So that's why we do this part in-house.
Good. We are in the tube butting station. Your specialty is that you butt tubes in-house. And I don't think I've seen anyone else do that. Why do you do it in-house?
The biggest reason is control the qualities because for the tube is most important for the bike process.
Did you have problems when you outsourced the tubes?
Yeah, sure, a big problem because before we have a lot of specification for the tubing, but the supplier they couldn't do that, and there is many details like how to make the quality stable and also the heat treatment issue. So the supplier they couldn't find out the most important problem, so we take it in-house.
Now you're going to show us how the tubes are made, and I'm excited to learn.
Let's do. Usually we will use raw material, so this one is a bigger and thick one.
So this one starts off extra thick
Yeah.
and larger diameter.
Yes.
And then it gets put into this machine.
Yes, then we will coming out, then become smaller and longer. Yeah, so
How many times do you have to go through the machine?
depends. Sometimes 2 times, sometimes 4 times. It depends on different specifications. So yeah,
Okay.
it's our secret.
Oh,
Between each button, we will have a heat treatment for the tube. Yeah.
have a lot of small stuff in between. Okay. I will just explain it, don't worry.
Don't worry, Agnes, I got this. The tubes start off as raw material, which are larger diameter and thicker than a bike tube. The tubes are coated in a special lubricant and placed on a hydraulic ram. The hydraulic ram forces a tube through a die, which forms its outer diameter. This process stretches the tube and thins it out. The exact number of steps and intermediate sizes in between each step is a trade secret. To reach its final dimension, a tube will be butted up to 6 times. If it's titanium, it has to be heat treated between every step. More on that later. According to Agnes, they run the machines much slower and have more intermediate steps, which stresses the material less and creates a higher quality end product. I knew most of the butting process up until this point, but there was one mystery that I did not understand. How is the inside of the tube actually formed? I know they use a mandrel, but how do they remove it? Won't the mandrel get stuck inside? I thought they must use some sort of expanding mandrel. The answer was simpler than I thought.
I have a mandrel here. I've never actually held one of these.
Usually each step will use a different mandrel. So this mandrel is very important to control the signals. Yeah, so we will do something details here to make sure the button process is correct. Yeah.
And this is part of your secret.
Yeah, of course.
This is a single-butted seat tube mandrel. The mandrel is thin where the seat tube inserts, creating a thick butt, and the rest of the mandrel is thick, which creates a thin wall thickness for the tube. Here is a double-butted mandrel. It is thin on both ends and thick in the middle. This is what confused me. If the mandrel is thick in the middle, doesn't it get stuck inside the tube? Turns out the answer is really simple. The mandrel just pops out. I was overthinking it. Metal can easily stretch, and the hydraulic ram is super strong. If you watch the slow motion replay, you can actually see the tube spring back. Look closely at the reflection. ORA has almost 1,000 different mandrels, allowing them to create hundreds of different tube profiles. Learning about their process made me really appreciate how much thought and craftsmanship goes into a simple bike tube. We use ORA's titanium tubes in some of our custom bikes. I've always noted that they feel higher quality than other tubes, and now I know why. The other thing we need to talk about is heat treatment. Titanium is an extremely strong material, and it does not like being formed. Between every butting step, it must be heat treated to relieve the stress.
How many times do you run the heat treatment oven?
Per week,
Yeah.
3 to 4 times, depends. Yeah, they put the argon inside. Yeah, during the heat treatment because they keep it inside vacuum.
I'm guessing it's really expensive to run.
Yeah,
Okay. Okay, that's good.
you got it.
Yeah.
If you learned something new about bike tubes, say, "Thanks, ORA," in the comments. Also, share it with your cycling group chat. Tubes are the soul of a high-performance metal bike, and I really respect ORA for taking the process in-house to have complete control. Now we go to the second floor, where the frames are fabricated. But first, lunch.
是不知道发生什么事。
We also discussed some new house and artifact projects that I'm really excited about. Now back to the tour. Agnes had to go do some real work, but she'll be joining us at the end for an interview. The second floor is where all of the frame fabrication takes place. The chainstays and the seat stays are bent on this hydraulic bender. I've seen a bunch of these benders in factories across Taiwan, and I really want one. Every stay is checked against the one-to-one drawing, and small adjustments to the bend are made if needed. This particular seat stay has bends in 2 different planes. It's extremely difficult to do accurately. This gigantic press forms the tubes. This is a titanium down tube being ovalized at the bottom bracket. ORA has hundreds of these chainstay, top tube, and down tube molds. Each mold is made from a giant chunk of steel. I thought these top tube molds were really cool. Titanium likes to spring back after being formed, so it takes a lot of experience to know how to machine the mold in order to achieve the final shape. ORA uses wire EDM to miter the tubes. I didn't even know this was possible. An electrical current is run through a thin wire. When it touches the tube, it vaporizes the material. This allows you to make precise cuts in very hard material. Flat mount brake tabs are notoriously difficult on metal bikes. Any misalignment can lead to brake rub. ORA has a very impressive solution. Not only is wire EDM extremely accurate, but they also miter and weld the first brake tab, then put the assembly back into the fixture and miter and weld the second brake tab. This decouples the distortion.
I feel like he's been avoiding me. He's been avoiding me every time.
This is a front triangle fixture. Notice how there are no markings or dimensions on it. This is because they have high confidence in their tube miters. A little fine tuning of the down tube seat tube notch. The final geometry is checked after tack welding and finish welding. Adjustments to the fixture are made as needed. According to ORA, it takes 1 hour to weld a steel frame and 3 to 4 hours to weld a titanium frame. This is a titanium weld. At high temperatures, titanium reacts with oxygen and oxidizes, contaminating the weld. Argon is being flowed over the weld to protect it from the atmosphere. Look how shiny those welds are. This steel seat stay subassembly is being welded. One thing that I found really interesting is that the welders are working on totally different projects instead of an assembly line. This gives more individual attention to each frame. According to Agnes, there's 5 to 6 different frame projects running at the same time. It's impressive to manage all those logistics. From start to finish, each frame takes 50 hours to complete. That's a lot of attention to detail.
Like that.
To avoid stressing the frame, alignment is done in multiple steps along the process, during tacking and after the final weld. This is a tire clearance check. This is a smart way of checking the drivetrain clearances. I'm going to steal this idea. This is ORA's digital quality control process. Not only is it more accurate, but it's also much easier to do. If you ever had to manually fill out a form or enter numbers into a spreadsheet, you know how annoying that is. I appreciate the effort to make employees' lives easier. Agnes talks more about this in the interview at the end. To pass, all dimensions need to be within 1/2 degree and 2 millimeters of the drawing. Having built frames myself, I know this is much harder to do than it sounds. One of my favorite things about titanium is that the raw material's appearance can be changed with different surface textures. Titanium forms an oxide layer with a combination of an electrolyte solution and electricity. Different voltages change the thickness of the oxide, which reflects different wavelengths, and are perceived by our eyes as different colors. By changing the roughness of the surface, you can also make titanium lighter or darker. It's a very environmentally friendly process. Beautiful process, beautiful factory, beautiful bikes. Good business is not just about products or materials, it's about people. ORA is a very progressive company to work with. They were kind enough to block off the entire day to help us film. So let's pay that back by listening to what Agnes has to say.
Update. I spent like 4 hours filming. Yeah. And probably end up with only 3 minutes of video. Kidding. I always learn a lot every time I visit. And I feel like it makes me appreciate the bikes a lot more. And also it makes me a better designer. Because then I can, sometimes when you see something, you can visualize it and then you can do it. So yeah, thanks for letting me run around.
Welcome.
Yeah. Do you want to start with a little history of ORA?
ORA history?
Founded by Jim.
Yeah.
Your dad?
My dad. Yeah,
And
my
when?
dad. 1996. Yeah.
So about 30 years.
30, almost 30 years.
Yeah.
Yeah. At the beginning, we just only have a welding process in-house, but Jim has found that is not enough to survive our customers. So we increase our capability and also step by step to make more process in-house. And we can do complete products to the customer directly. And also we can get some important details in-house.
What do you think makes ORA special?
I think it's total solution provider.
So from design, engineering, tube spec, fabrication, finish, shipping, entire solution.
Yeah.
You've been kind of managing the company for the last 5 years as VP. What makes you the most proud that you've done?
I do a lot of digital systems in-house. Yeah, but
What do you mean by digital system?
unlike the QC system and
Oh, I see. So
system.
modernizing.
Yeah.
Oh, I see.
Yeah. Before we get a lot of paper work,
Yeah.
but we change it to a digital system. Then there is less paperwork.
Yeah.
Then
More efficient.
more efficient.
Yeah. Better result, more accurate.
Yeah, and our employee, they don't need to get a paper and talk all around the factory to find the manager. Just sign.
Yeah.
In the production line, the manager is really busy, and they usually walk around everywhere, so it's hard to find it.
I see. Okay. Yeah, that's very impressive. I think, change is always hard. Like even in the American medical system, everything is still, most of it's still paper because people don't want to change.
But you have to face, because the young people, they don't want to do that.
Yeah, it's frustrating. If anything that's slow, it's very frustrating.
Yeah.
I guess what you're proud of is digitizing, optimizing, making things more efficient.
Yeah.
Yeah. I think one thing that I don't think gets talked about is that's actually really good for workers' health too, because when you have a job that is frustrating or mentally difficult or annoying, it's not good for people. So it's good to see.
Yeah.
I think people can do a better job when they're
Yes, and they don't need to overwork.
yeah.
I think that is very important for the next generation people, because they want to find a balance between the work and family time.
People talk about that, corporate talk about that, but it's good to actually see that, because when I see the workers, they seem pretty chill. Some of the factories I go to, is like, I would never want to work there, but
Usually it's talk a lot, but no act.
Yeah. Oh, that's good to see. Okay, that's good. Softball.
Can you all totally agree that?
Yeah. Agreed? Okay, let's try this one. I'll say it right now so you can think a little bit. What do you think makes ORA different from other manufacturers? We're not recording, just asking.
Give me a GONG.
Oh, okay.
Yeah.
No, are you really going to show it?
Yeah, I really want to show it.
Okay. Okay, let me ask. Are you gonna bring it up like this? Okay. Yeah. Okay. All right. Okay, I'll ask the question.
Yeah.
What do you think makes ORA different from other manufacturers? So important that you even made a sign for it.
Yeah.
Do you want to? What is GONG?
GONG? It means to be better together.
Yeah. What does that mean in the context of ORA?
Usually we provide the service to our customers. Not only we want to earn the profit, because we also want to help our customer to be successful.
How do you help the customer be more successful?
To find a suitable product or the suitable cost to customer.
Yeah.
Because sometimes customer, they just only have ideas, but they don't know it works or not. Yeah, so we will give them some feedback, but our position is we also want to customer to be successful.
Yeah.
We don't just want to earn the money from customer.
Yeah, that's one thing that I actually appreciate, and also makes it difficult, but it's good to have friction, is you don't say yes to everything. I think some companies will just say yes to all designs.
Don't do that.
Yeah, and I actually appreciate that you provide feedback on things that you don't feel comfortable doing or things that you think is a better design. And normally I think it's easy for companies to just say, okay, we'll do it, not a problem, and then take your money, and then problems go down the line.
But
So,
we don't do that. Yeah, even to our supplier,
yeah,
we do the same way. We respect everyone.
I see.
Yeah, and I think that's a good way to make good cooperation.
Yeah.
Yeah, and everyone can to say something. Yeah, and we can work together to let the product or project to be better. Yeah.
So Gong. How. Gong, what does gong mean?
Together.
Together, how is better.
Better. Yeah.
Okay. Together better. Better together.
Yeah.
Cool. How should people follow Aura?
Sign our newsletter on website.
Okay, I'll just I'll finish this one for you. If you want to keep up with Aura, newsletter,
Yes.
Instagram,
Yes.
YouTube,
Yes.
and you guys will be in Taipei show.
Yeah.
Okay,
Good.
Done. Finished it.
Good.